Okay, I think we can get started. It's almost UofT time. So FYI, this meeting will be recorded. So if you don't want to appear on camera, you can stay without your camera on. Yeah, so these are all topics we're going to cover today. It's great that I see that there's a lot of input, so that's great. Okay, yeah, so this is our first official meeting. We'll be going over the contents that we learned through the past 2 weeks. So I will be walking through some of the concepts, and we'll also, for you guys who are here, we're going to try out some breakout room discussions as well. Yeah, so let's get started. So first, I think like in the beginning, some of you touched upon some of these topics as well. So these are the topics that we're going to go through today. So there's linear regression versus classification, loss functions, activation functions, gradient descent, and finally overfitting and regularization. Okay. So we're going to start off with an activity. So we learned about linear regression and classification. These are some common machine learning and deep learning problems that we can see. So just want to start off, if you could go on Slido and then use this ID and submit some linear regression and classification examples you can think of, just to get the ideas flowing. And I'll also try to submit some as well. I'll give a few minutes for you to do this. Yeah, image identification. Yeah. I think for in later one of the modules is specifically dedicated to images. So yeah, that's definitely a big area. And then house price. Yeah, I had this in mind as well. Like since I live in Toronto and the house price is pretty high right now. Yeah, spam. And then features. Yep, salary predictions. Yep. Okay. Let's move on. So yeah, so to put this in the graph, on the left side, there's classification, and on the right side, it's regression. So like one example I had in mind was cat versus dogs. So like some of these data points could be cats and others could be dogs, and then we have to classify them. I think it can also count as image recognition. Yeah, in image classification as well. And then regression, like some of you mentioned, like house price or salary price. Like for example, like the x-axis could be like how big the house is or its location, and then the vertical axis could be like the price. So yeah, these are like two different kinds of problems that we can encounter in machine learning. Yep. Next slide. Okay, so I want to try out some breakout rooms since we want to keep it like more like discussions. So I'll try breakout room of 3 people for around I think 5-ish minutes, and then please as a group, each person just go through these questions listed here just to recall some of the knowledge that we learned, and then actually I'll paste the questions in the chat as well, so you'll be able to see them in the breakout rooms. Yeah, so please go through them, and then we'll come back and then go through them together. Let me just try to open the breakout rooms. So we have 18 people. Okay. Sorry, just setting up the breakout room. Okay. Yeah, the breakout room should be open. Yeah. Hello, everyone's in breakout rooms right now. So I'll add you to a breakout room and we're just going through these questions right now. Let's see. Oh, oops, sorry, not now. How do I assign? Oh, here. Okay. Okay, let's just wait for everyone to trickle back. Let's see. Okay, so activation functions. So first, how are they useful? So they're useful because they map the result to specific ranges, and that could make the result more meaningful. And the second question, difference between linear and non-linear. The answer is sort of in the question. So one's using linear functions and the other is using nonlinear functions. Linear functions are more simple, whereas with nonlinear, it could have a more variety. So like in different cases, it's more applicable to use one or the other. And I think more commonly, nonlinear activations are used more often. So various types. I've listed the two that I remember the best here. So the sigmoid, it has a range from 0 to 1, as you can see in the graph here. And so going back to the first question, like this activation function could be helpful since it's from 0 to 1. So it can represent a probability. And sometimes we want the result as probability, which could be pretty useful. And the value activation function, I think it's pretty much the most common one that's used these days, since it makes the model easier to train and has a better performance. So I mentioned this in the kickoff meeting as well. If you'd like to get more details like about the other different types of activation functions, because there is a lot, we have a GitHub page set up for our study group. The link is in our under the resources channel in our study group server, and then you can learn more about the other types of activation functions in these things. Yep. Okay, next topic. Okay, it's another Slido poll. So loss functions are used to evaluate the accuracy of our predictions. So just want to get our ideas flowing. See if like which activations you can recall, and then again it's slido.com and then this ID. Yeah, let's see which loss function is the most popular. Let's see. Okay, just a few minutes to do that. Let me check the chat. Looks like there's some question. So which module is activation functions? Okay, so while you're doing this, I'll quickly show you which module activation function is introduced. Let's see. Okay, so under week 1, so week 1 is basically module 1 for us since we're not going by weeks. But I think activation functions, I think it was, yeah, good point. I think it was under, when it was going through like linear regression and classification, they went through like some of their respective activation functions that were used. Yeah. Okay. Wow, triplet loss. Okay. Okay. Next slide. Okay, loss functions for me. I remember mean squared error, so MSE loss, and then cross entropy. So MSE is used for regression kind of problems, and cross entropy is used for classification problems. I think like these are generally the more common ones used. And so for mean squared error, it penalizes wrong predictions that are further away. And for cross entropy, it penalizes wrong predictions that are confident. So I think I've listed the formulas here. I think we've seen like MSE formulas generally in like math. So this one is probably more familiar to us. But yeah, these are I think the more common loss functions used to basically just to evaluate the accuracy of our predictions. Yeah, so they're pretty useful. Okay, we're gonna try out another breakout room session. This time we're focusing on optimization algorithms. So in breakout rooms, try to brainstorm together like these definitions and see if you can remember what they mean. I will set up the, I'll paste the concepts in the chat. So just to recall some of the concepts, I will open up the breakout rooms. Let's see, recruit. Okay, I think 10 minutes-ish should be good. I'll open them up. Okay, let's wait for everyone to get back. Okay. Yeah, so I listed my interpretation of it here. So in a lot of the problems, we're often trying to optimize. An optimization algorithm helps to find, let's say, a function's min max. So I have to make it easier to understand, I have it visually as well. So let's say like our problem could be like trying to get to the bottom of the mountain. So we're trying to optimize for this min point right here. So yeah, that's an example. And then gradient is the direction of the steepest ascent. So let's say we're here and we're trying to optimize to go down the mountain. We want to try to go from the steepest direction. Like if you go sideways, then it'd be harder to get to the bottom, right? Yeah. So that's gradient. And then gradient descent is, I think it's one of the most common optimization algorithms used in machine learning, and it's first order, so it uses the first derivative. And then the learning rate, it's the size of the step in each iteration. So like while you're trying to optimize, how big of a step you're gonna take. Of course, like there's good and bad sides of taking a large or a huge step or a small step. So it's best to find the most optimal learning rate slash size of each step. And then for gradient descent, there's a specific type of it called stochastic gradient descent. So it's random, so it randomly, because like when you're calculating gradient descent, often you have to compute a lot of data. So if you randomly select the data point to represent that pool of data, then makes it easier to compute. So as you can see, not sure, the legend here might be a bit small, but in purple it's stochastic gradient descent, and you can see it's more random. Yeah, but it makes the computation easier. Yeah. Okay, so that's for optimization algorithms, I think. Yep. Okay, the last topic was regularization. So this is a techniques used to discourage learning a model that's too complex for the problem, and it's also to avoid overfitting. So I put this image here to demonstrate what it is. So let's say you have these data points, and at first you learn a little bit, and then you learn to fit a straight line to it. As you can see, like the straight line doesn't really represent the data that well. So you train a bit more. Then you see I'd say this is a nicer fit. But then if you train way too much and makes the model way too complex, then you've overfitted, right? As you can see, like this is way too complex to represent the data. What's in the middle here is it's the good fit. Yep. And just to go over some regularization techniques. So there's weight penalty. So you want to prevent large weights because large weights are heavily affected by like the slight changes in feature. So you want to prevent large weights to prevent overfitting. And there's also data augmentation, which I find to be pretty cool. So I've put an image here. So if you only have, let's say, a picture of a dog, a very cute one, you can augment the data slash image in different ways. So so essentially you're producing more data, and that helps to prevent overfitting. And then dropout, it basically drops nodes in your network, so it prevents it from becoming too complex. And as always, I think in machine learning, more data is always, well, I don't want to say always, but most of the time it's better to have more data. So yeah, more data always helps because you have more to learn from. Yeah. Yeah, so that's all I have for today. Thank you very much for joining. And I've put a feedback form here in the slides, and it's also pinned in the general channel. We really welcome any feedback that you have, any feedback about the way we're doing these discussion sessions, or if you have any recommendations on the format, please, yeah, just let me know here. And also before you go, I have a poll on Zoom. I'm gonna launch it right now. Please it's just two very quick questions just to get a sense of the pacing and the difficulty, like how everyone is feeling. Yeah, and we'll adjust our stuff. Since it's the first week, we wanna just to get your feedback on this. Yeah. Yeah, thank you. And you're free to go if you have other things. I'm sure you have lots of things to do. And yeah, let me know if you have any questions. I'll just be here to answer any questions if you have. And our next meeting will be in 2 weeks. I'll post more stuff in the channel for like in terms of next step, what we're doing for the next 2 weeks, etc. Yeah, no problem. Thank you.
Excuse me. So when it comes to the, I think there was an assignment and a lab for the course. For the first week, are we supposed to have done them?
So for the past 2 weeks, so up to today, so we plan for the week one's content, so the readings, videos, and the 2 quizzes. I think you're referring to the programming assignment / lab. That's for the next 2 weeks. Does that answer your question?
So, so linear models and optimization programming assignment is for the next 2 weeks.
Yep. Yes, exactly.
I see. And the lab too. Okay, yeah, that makes more sense. Thank you.
Okay, yeah, no problem.
But to access it, are we only able to like download the files when we generate the token, or?
To access this assignment?
Yeah.
Oh, did you? I haven't clicked into it yet. Did you have any trouble? You had trouble accessing it?
No, I haven't generated a token yet, but I can't find any place to download the file. And there's like, I vaguely remember reading that there was like a time limit after using the token.
Oh, really? Oh, wow. Okay. I'll try to access it and then let you know. Is that fine?
All right, yeah, thank you.
Yeah, no problem.
Hello.
Hello.
How are you?
I'm good. How are you?
I'm fine too. So, for the like past 2 weeks, I had some problems with my school and stuff. So I couldn't have a chance to like look at the first 2 models. I'm planning to like finish the first one today. So is there any problem because like the first UT is passed for the first one? Is there any problem like if I finish it this week and the second one like in this week also?
So if you're referring to just Coursera, I think there should be, I don't have it here because I reset my deadlines, but on the top of your screen, there should be like a place to reset your deadlines. So if you click into that, it will reset all the deadlines. So there shouldn't be any issues on the Coursera side in terms of the deadlines. You can reset it as many times as you'd like. Yeah.
Besides Coursera, is there any like something else?
For our study group side, I want to make it flexible. So yeah, no, don't worry if it might be a bit tough to finish everything. But for now, because I'm also trying to I'm thinking of sending a poll to see like each person's pace. But for now, it's just that our meetings will be going through the concepts. But you're free to take things on your own pace. Yeah.
Okay. Like, do you mean can I arrange my like own schedule?
Yeah, for sure. If you like, yeah. I don't. I want to make this. I want to make this flexible as well for everyone. So.
Okay. Okay. Thanks for that. Thanks.
Yeah, no worries.
Okay, then have a nice Sunday.
Oh, yeah, you too. Thank you.
Bye.
Bye.